Assalamualaikum and hi everyone. So in this video, we will learn about the equilibrium of bodies in a system of force. What do you mean by equilibrium? It means that the particle or the object doesn't move to the right, to the left, or up and down. So it is in a static mode. Okay. If forces are in equilibrium, then the resultant or the sum of vectors is equal to 0. So it means that the I component is 0 and the J component is also summed to 0. Okay, let's look at the example 2. A particle is in equilibrium at O under the force shown in the diagram. Find the values of P and Q. Okay, so the first step is we need to find the x component of the force and also the vector. The x component and also the y component. So let's say this is number 1, 2, 3. So let's start with P first. So the x component for this vector P is P, and then the second one is Q cos 60. And then the third one is 0. So because it is in equilibrium, so the x component should be equal to 0. And then for Fy, 0 plus Q sine 60 minus 12 is equal to 0. Now you have two equations and also two unknown. So you just do the simultaneous equation. So from the y component here, you can directly get Q, which is 13.86. The magnitude of Q is 13.86. And also, we can find P. So we substitute Q into the x component equation here. So we will get P is equal to Q cosine 60. So your answer is 6.93. Okay, let's move to the second question. A particle is in equilibrium under the action of 4 horizontal forces of magnitude 5 Newton, 8 Newton, P Newton, and also Q Newton. So for this question, it asks you to show that P is equal to 9. Okay, let's say this is number 1, 2, 3, 4. Okay, let's find the x component, the sum of the x component for all these 4 vectors. So we have Q, we have 0, and then the third one is 8 cosine 30 plus 0 is equal to 0. So this one is straightforward, so you will get Q is equal to 6.93. So we already answered for B. But now the question asks you to show that P is equal to 9. So we have the y component 0, 5, 8 sine 30 minus P is equal to 0. So this one is also straightforward. So your answer is 9 shown. Okay, let's look at question number 3. The diagram shows 3 forces which act in the same plane and are in equilibrium. Okay, let's start with the x component. Okay, let's say this is number 1, 2, and 3. So we have F cos theta, A cos alpha, minus 6, then plus 0 is equal to 0. Fy, so we have F sine alpha minus 5 equal to 0. So now you have two equation and also two unknown, which is you have F and also alpha. So you can do simultaneous equation. It's either by using substitution method. You can find F or alpha and then substitute into the another equation. Or maybe the simplest way is just by using some technique that you can just simply cancel the F. So if let's say we have sine and cos, maybe we can consider tangent is a combination between sine and cos. So f sine alpha is equal to 5. So we get from the x component. And also we have f cosine alpha is equal to 6 for the x component, y over x. So we can just simply cancel off f. So we get tangent. So we get tangent alpha is equal to 5 over 6. So we can get alpha is tan inverse 5 over 6. So your answer would be, alpha would be 39.80. Okay, then how are you going to find f? Just substitute into the any equation. These two equations. So let's say I put in sine. So equal to 5. So f sine 39.80. So 5 over sine 39 over 680. So my answer is 7.81. Okay, let's look at the fourth example. Okay, find the resultant of the following system and state the force needed to maintain equilibrium. So again, the sum of fx must be equal to 0, and also the sum of fy must also become 0. So let's do for fx. Okay, summation of fx. Okay, just simply write fx. So it is known that it's a combination of the x component. So let's say this is number 1, 2, 3, and then we have 4. So we have 10 cosine 25 minus 12 sine 40 minus 6 cos 65 plus 0. Okay. Okay, and then the question is find the resultant. Okay, for this question it's quite different because it asks you because it has a resultant force or a resultant force, and then it states that the force needed to be maintain equilibrium. So it means that the summation of the x component, you just use your calculator, so you will get negative 1.19 because there exists a resultant vector, and then we need another force to make it maintain equilibrium. Okay, so I will show it later how we're going to find the force. So Fy we have 10 sine 25 plus 12 cosine 40 minus 6 sine 65 minus 5. So I get 2.98. Okay, now let's try to draw. If let's say that there are an additional question, draw or sketch the resultant vector. Okay, so you know that fx here is in a negative, and also fy is in a positive. So if let's say it is negative for the x component, so it can be at the second or at the third quadrant. But for fy it is a positive, so fy can be at the first or the second quadrant. So we can see here that the resultant is actually, because it satisfies both here, so it means it is at the second quadrant. So if let's say we do not know the direction, we don't calculate it here, but let's say it is something here. So this is the resultant force. Okay, so let's maybe I can just rewrite it as FR. So this is the resultant vector. So if let's say this is a particle and it is pulled by 4 force, and then the resultant the particle will move to the right to the orange force, towards the orange force here. So it's moving to the second quadrant. So how are we going to make it maintain equilibrium? It means static. We don't want it to move. Okay, so because so the answer is how to make it maintain equilibrium. So if let's say it is pulled to the second quadrant, so we need to have another force to at the fourth quadrant to make it equilibrium. So the difference is the positive and negative direction. Okay, so we need another force, which is, if let's say this is negative 1.19, so we have 1.9 I, because if we want to represent as a vector, and then we have a positive 2.98, so minus 2.98 J Newton. So this is the force needed to maintain equilibrium. It's the green one. Okay, for question number 5, the system is in equilibrium, but we get the figure is like we have 3 arrow, and then from one point B here. So there are 2 ways by using triangle of forces and also the Lami's theorem. So I will continue this later in the next video.